Section: Introduction. In this section, we discuss conversational agents powered by large language models, LLMs, that are widely used in various applications like customer service and personal assistance. Some well-known examples include OpenAI's ChatGPT and GPT-4, Anthropic's Claude 2 and Claude 3, Google's Bard, and Microsoft's Bing Chat. Together, these systems cater to millions of users. The development process for conversational agents typically involves three phases: pre-training the LLM, fine-tuning it on an instruction tuning dataset to align with human expectations, and optionally using reinforcement learning from human feedback, RLHF, to enhance the model's responses based on human preferences. While the training data for the base model is easily accessible, the crucial instruction tuning datasets are often private, creating a barrier for researchers aiming to progress in the field. Existing datasets for user-chatbot interactions mainly fall into two categories: natural use cases and expert-curated collections. However, except for the LMSYS Chat 1M project, natural use cases involving real user interactions are usually not publicly available. Consequently, researchers often have to rely on expert-curated datasets, which may not accurately represent real-world interactions and are often limited to single-turn conversations. To address this gap, we introduce the WILDCHAT dataset, a comprehensive collection of multi-turn, multilingual conversations totaling 1 million, with over 2.5 million interaction turns. These conversations were gathered through a chatbot service using the ChatGPT and GPT-4 APIs. The dataset includes demographic information such as state, country, and hashed IP addresses, along with request headers, enabling detailed behavioral analysis over time and across different regions. Importantly, all data was collected with explicit user consent. The WILDCHAT dataset serves multiple research purposes. Firstly, it provides a closer representation of real-world, multi-turn, and multilingual user chatbot interactions, enriched with demographic details for more detailed behavioral analysis. Secondly, it reveals a surprisingly high level of toxicity in interactions, highlighting the need for intervention and offering a valuable resource for studying and addressing toxic chatbot interactions. Lastly, we demonstrate the dataset's effectiveness in fine-tuning chatbots, showing that simply fine-tuning a language model on the raw dataset can produce a strong chatbot, indicating its potential for further curation to create improved instruction tuning datasets. To collect the WILDCHAT dataset, we deployed two chatbot services powered by the GPT 3.5 Turbo and GPT-4 APIs, hosted on Hugging Face spaces and made publicly accessible. We collected chat transcripts, IP addresses, and request headers, ensuring user anonymity and accessibility without the need for user accounts. The dataset compilation covers conversations from April 9, 2023, to May 1, 2024, with ongoing updates planned. To uphold ethical standards regarding data collection and user privacy, we implemented a user consent process where users had to agree to terms of data collection, usage, and sharing before accessing the chat interface. User privacy was prioritized by anonymizing personally identifiable information using various tools and techniques across multiple languages. Additionally, IP addresses were hashed to further protect user privacy. Section Summary. In this section, we introduce the development pipeline for conversational agents powered by large language models, LLMs, which involves pre-training the LLM, fine-tuning it on an instruction tuning dataset, and optionally applying reinforcement learning from human feedback, RLHF. We address the challenge of limited accessibility to instruction tuning datasets by presenting the WILDCHAT dataset, a multi-turn, multilingual dataset of 1 million conversations collected via ChatGPT and GPT-4 APIs, enriched with demographic details for behavioral analysis and showcasing its effectiveness for instruction tuning chatbots. Section: Dataset Analysis. In this section, we will present the key statistics of the WILDCHAT dataset and compare it with other conversation datasets. We found that WILDCHAT contains a wide variety of languages, diverse user prompts, and showcases different types of toxic behaviors. When looking at the basic statistics, WILDCHAT consists of 1,009,245 complete conversations contributed by 204,736 unique IP addresses. Around 24% of the conversations use the GPT-4-based API, while 76% use the GPT 3.5 Turbo-based API. Over time, there has been a decrease in the use of GPT 3.5 family models, with more conversations coming from the GPT-4-based API since January 2024. On average, each conversation involves 2.52 rounds of interaction between the user and the chatbot. Geographically, most of the data comes from users in the United States, Russia, and China. In terms of prompt categories, we analyzed 1,000 conversations and found that common categories include assisting or creative writing, analysis or decision explanation, and coding. We also identified 68 languages used in the dataset, with English being the most common, followed by Chinese and Russian. Comparing WILDCHAT with other datasets like Alpaca, Open Assistant, DALL-E, Shared GPT, and LMSYS Chat 1M, we observed that WILDCHAT and LMSYS Chat 1M stand out for having authentic user prompts from real interactions. WILDCHAT also provides longer user prompts and chatbot responses compared to the other datasets. In terms of language diversity, WILDCHAT and Open Assistant have a more diverse range of languages compared to Shared GPT and LMSYS Chat 1M, where non-English data makes up a smaller percentage of the conversations. To assess data coverage, we fine-tuned a model on each dataset and measured how well they could explain data from other datasets. The model trained on WILDCHAT performed well when tested on Open Assistant and Shared GPT, indicating good coverage. In analyzing toxicity, we found that a small percentage of user turns and chatbot responses in WILDCHAT were classified as toxic. There was limited agreement between the toxicity classifiers used, with sexual toxicity being the most prevalent type. WILDCHAT showed higher toxicity ratios compared to other datasets, making it a valuable resource for studying toxic behaviors in user chatbot interactions. Section Summary. In this section, we present basic statistics of the WILDCHAT dataset, which includes over 1 million conversations from diverse users and showcases various languages and toxicity phenomena. The dataset features conversations with an average of 2.52 interaction rounds per conversation, with a gradual shift towards GPT-4-based API usage over time. Additionally, a comparative analysis with other conversation datasets highlights WILDCHAT's unique characteristics, such as authentic user prompts and longer user chatbot responses, making it a valuable resource for studying toxicity and language diversity in user chatbot interactions. Section: Toxicity over time. In this section, we examine the changes in toxicity levels over time in user and chatbot interactions. Initially, during April and May 2023, the chatbot was more toxic than users. However, this trend shifted after June following an update to the OpenAI model, leading to a decrease in toxic chatbot interactions. Since then, we have observed a consistent reduction in toxic chatbot behavior. We also delved into the issue of jailbreaking, where users try to manipulate chatbots into producing inappropriate responses. We found that social media platforms play a significant role in promoting jailbreaking behaviors. By analyzing specific jailbreaking prompts, we identified common tactics used by users and their success rates. For instance, the prompt, "Jail Mommy," had a success rate of 71.16%. This highlights the importance of developing adaptive defense mechanisms to address evolving toxic content and jailbreaking techniques. Furthermore, we focused on fine-tuning chatbot responses to align with user preferences through instruction following. Using the WILDCHAT dataset, we fine-tuned a Llama 2.7b model to create a new model called WILDCHAT. For training WILDLLAMA, we utilized data collected until July 16, 2023, and followed similar procedures as the Vicuña model. We fine-tuned WILDLLAMA using specific parameters and hardware for 3 epochs. Evaluation of WILDLLAMA using LLM Judge on MT Bench showed promising results, outperforming other open-source models of similar size but falling short compared to proprietary models like GPT 3.5 and GPT-4. Detailed performance breakdown by dimension indicated strengths in roleplay and coding but weaknesses in responding to extraction prompts. Considering user demographics, our chatbot's hosting platform may attract IT community users, potentially skewing the dataset towards coding-related conversations. The anonymity provided by our chatbot could lead to a selection bias towards more toxic content, similar to observations on platforms like Hacker News. Overall, our findings emphasize the importance of addressing toxicity and jailbreaking behaviors in user chatbot interactions while striving to improve model performance and user experience. Section Summary. In this section, we analyzed the toxicity rate of user and chatbot turns over time, observing a shift in toxicity trends after the June 27 OpenAI model update, leading to a consistent reduction in toxic chatbot interactions. We also investigated jailbreaking behaviors, noting users attempting to manipulate chatbot responses, with the most successful prompt being, "Jail Mommy," at a 71.16% success rate. These findings emphasize the importance of developing adaptive defense mechanisms to address evolving toxic content and jailbreaking techniques in user chatbot interactions. Section: Usefulness of more data. In this section, we discuss the usefulness of having more data. We suggest that even a small set of high-quality examples could be enough to align a pre-trained language model with human preferences, which challenges the idea that large datasets are always necessary. Although our dataset is large, we question whether such abundance is always essential. However, the strength of our dataset lies in capturing real-world user interactions, which are crucial not just for training better chatbots but also for improving user modeling and studies. When it comes to ethical considerations, the release of WILDCHAT raises some important points. Even though our service doesn't require user accounts, providing a level of anonymity, there is still a risk that users might unintentionally share personal information during their conversations. To address this concern, we have removed any personally identifiable information to safeguard user privacy. Moreover, we only share hashed IP addresses along with general geographic details at the state level, making it impossible to trace a conversation back to an individual user. Additionally, all data releases undergo thorough internal reviews by the AI2 legal team to ensure compliance with data protection laws and ethical guidelines.